In science, we're taught the rules are pretty simple, right? A theory makes a prediction, you go out and measure reality, and if they don't match up, well, the theory's wrong. Back to the drawing board. But what if a theory came along where its core prediction was that it shouldn't match our measurements perfectly? What if that tiny little bit of wrong was actually the whole point? So let's start with this number. This is the fine structure constant, usually called alpha, and all you need to know is that it basically governs how light and matter talk to each other. And we have measured this thing with almost unbelievable precision, down to parts per billion. It is one of the most solid, unshakable facts we know about our universe. And right away, here's the puzzle. On one side, we have a value for alpha that comes from pure geometry. Just beautiful, elegant math. No extra bits, no fudge factors. It gives us this number. And on the other side, we have the number we get from countless real-world experiments. And they are so close, but they are not the same. For decades, that tiny gap has driven physicists nuts. So what's the deal with this tiny difference? Is it just a simple failure of the geometric theory, a really good guess, but ultimately a near miss? Or is it something way more profound? Could this little bug actually be a feature, pointing to a whole new way of looking at reality itself? Well, to even begin to answer that, you have to look at it in a completely new way. And this is where a theoretical model called the Universal Field Resonance Framework, or UFRF for short, enters the picture. It makes the wild claim that this mismatch isn't just something to be expected, it's required. It suggests that maybe the way we've been measuring the universe has a fundamental blind spot. Okay, so the UFRF is built from the ground up on 5 big ideas, or axioms. First, it says reality isn't made of particles, but of a single electromagnetic process. Second, and this is a big one, all our observations are just projections. Third, scale itself isn't fixed, it's relative. Fourth, everything in the universe evolves through a repeating 13-step cycle. And finally, all the fundamental constants we see, like alpha, just fall out of pure geometry. Yeah, it's a total rethinking of, well, everything. So I want you to forget everything you've learned about little solid balls of matter. In the UFRF, the fundamental building block of reality is this, a self-sustaining vortex of electric and magnetic fields. Think of it like a tiny, perfectly stable whirlpool of pure energy. A photon, that's the simplest version. An atom, that's just a more complex, stable pattern of the exact same vortex. So the universe isn't made of stuff anymore, it's made of geometry and motion. And this motion isn't random. It follows a very strict pattern. Every single one of these energy whirlpools evolves through this 13-position cycle. But see that one, right there, position 10? It's called rest. And this one is special. It's not just another step in the dance, it's a unique geometric gateway, and it is the key to understanding how all of this connects back to the world we can actually measure. All right, so now we get to the really big idea, the thing that explains that mismatch we started with. It's called the universal projection law. And this is how the theory builds a bridge from its abstract geometry to the hard numbers we get in our labs. So here's what the projection law says. It basically states that we never, ever measure the true intrinsic value of anything. What we measure is always a projection, a kind of perspective that gets distorted by the difference in scale between us, the observer, and the thing we're observing. It's like there are no absolute rulers in this universe, only relative viewpoints. Think about your shadow for a second. Is your shadow a wrong version of you? No, of course not, right? It's a perfectly accurate two-dimensional projection of your three-dimensional self. The UFRF argues that our scientific measurements are exactly like that. They aren't wrong, they're just lower dimensional projections of a higher dimensional reality. And okay, this is where it gets really interesting. The UFRF doesn't just say, hey, a projection exists. It actually predicts the exact size of that projection. So the theory's pure intrinsic geometric value for the fine structure constant is 137.0363. Then the theory calculates the projection effect, which is this tiny negative number. And when you put them together, you get the exact value we observe in our experiments. The mismatch isn't a failure. It's the theory's biggest prediction coming true. All right, so that's a pretty mind-bending idea for a fundamental constant. But you might be thinking, does this framework apply to the real world, with all its messiness? Well, let's put it to the test with a genuine scientific mystery that has stumped physicists for decades, sonoluminescence.
Sonoluminescence sounds like science fiction, but it's real. You use sound waves to trap and then violently crush a tiny bubble of air in water. And right at the moment it's smallest, it lets out this incredibly brief, incredibly bright flash of light. The temperatures inside are thought to hit tens of thousands of degrees. It's literally a star in a jar. But how? How is that even possible?
Well, from the UFRF's perspective, that sound wave is doing a lot more than just squishing a bubble. It's acting like a cosmic piston, forcing the E by B vortex of the bubble's energy field to race through that 13-position cycle we talked about at just an unbelievable speed. And at the moment of maximum collapse, where does that journey end? You guessed it, it hits position 10, the rest state. The theory predicts this is a unique geometric gateway where the fundamental forces are in this perfect balance, allowing energy to just instantly switch forms, in this case from the mechanical energy of the sound wave into the electromagnetic energy of light. And at this exact rust position, something else amazing happens. The very specific geometry of this gateway acts as a universal energy amplifier. The energy transfer gets multiplied by a very specific factor, the square root of the golden ratio, phi, which is about 1.272. And this isn't some random number they pulled out of a hat. It falls right out of the geometry of position 10. It explains why that flash of light is so incredibly powerful. Now, this is where the theory makes its most audacious claim. The UFRF argues this whole mechanism, the contraction, hitting the position 10 gateway, and getting that precise golden ratio efficiency boost, is universal. The exact same process that explains the tiny star in a jar, according to this theory, also describes how energy is emitted at the event horizon of a black hole. It's the same fundamental physics, the same geometry, just operating at two unimaginably different scales.
So, what are we supposed to make of all this? If a framework that starts by embracing a mismatch between prediction and observation can potentially explain mysteries from fundamental constants all the way to sonoluminescence, what does that really tell us about the nature of reality?
The philosophical implications are, well, they're huge. It suggests that reality isn't a collection of separate things, but a single, interconnected geometric process. That feeling of separation we all experience is just an illusion, an effect created by our unique perspective, by the projection from our scale onto another. Every measurement we take is a valid piece of the truth, but it's always an incomplete one. And that leaves us with one final provocative question. We started with a number measured to stunning precision, something we thought was a bedrock fact of our universe. But this theory suggests that even that is just a shadow on the wall. So if every instrument we can ever build, every observation we can ever make, is just one more projection from our unique place in the cosmos, what does the universe really look like when no one is watching?